Hey, today's video is going to be a little different than my other videos content-wise. Usually my videos are about making things or working with microcontrollers, but I spend my days building websites for a living, so I figured maybe I could do some videos about that stuff too. As the title suggests, this video is going to be about advanced React debugging and by proxy JavaScript debugging as well. I work in Windows most of the time and I use Chrome for development usually, so that's what I'm going to be using for this. But things like VS Code and Chrome are available for Linux and Mac OS, so there should be nothing here that's OS dependent. I'm going to start very simple and then ramp up the techniques to hopefully give you a lot of tools to deal with a lot of different things. So this video should really be for anyone, and if you feel like at some point things are kind of going over your head, I would still invite you to sit through the whole video just so you have some exposure on this kind of stuff. And as you do more development, I think it'll start to make more sense. And if you feel like the beginning of this video is just too basic for you and very boring, I invite you to jump further into the video. Hopefully there's something there that'll be interesting to you. All right, so let's get started here. So I generated a stock TypeScript React site using Create React App, and then I just gutted some of the stuff out of it and added a bunch of my own. I did add the React Router DOM library for page routing, and then after that I made a user context over here for sharing the user state between a bunch of pages, and finally I made two pages. The first is a home page, and the second is a user page. So all these pages were just jammed together in about 15 minutes, and there's not really meant to be an example of how you should build a good React site. I just needed something that I knew was broken in a certain way to demonstrate some points. So please don't look through this code looking for like juicy tidbits or something. It's not prepared to be that kind of demonstration. So all right, let's take a look at the issue that we're going to be debugging here. What we're going to look at here is a React state update error you'll sometimes find on pages that pull data from an API on page load. So if we click the login button, it's going to pretend to hit a backend to log the user in. When that's done, we can get into the user page. This page pretends to pull some data off the server when it loads. We can filter that data. And finally, we can log out from the user page, and it will pretend to log us out and bump us back to the home page. Every time we pretend to load data from the backend, we hide all the pages and show loading message. And when that completes, we make sure we bounce the user back to the home page, just in case the page they were on previously, they're not allowed to be on anymore. So as you can see here, when logging out inside the user page, we end up with this error here about performing a React state update on an unmounted component. That's what we're trying to debug in this. If you already know what the bug is, hopefully the rest of this video isn't infuriating for you, but we're going to take our time getting to it. So the first thing I'm going to show you is how to debug the React app directly in VS Code. I don't usually do this, to be honest, because I use all kinds of browser features when I debug things. But just in case you're into this methodology for some things and it's not obvious, I'll show you real quick. I'm using Chrome, so the first thing we need to do is make sure the debugger for Chrome extension is installed in VS Code. And you can do this with Firefox and Edge if you'd rather go that route too. So make sure you install that extension. And then we're going to come over here and just open any file from our site. And finally, click the debugging tab over here and click Run and Debug. At this point, it'll ask you to select an environment. And we're going to select Chrome right here. And it's going to make a launch JSON file for us. And in here, because this is a Create React App site, we're going to change the port to 3000. Now, before I actually do any debugging, I do need to actually start the site. If you do end up messing this up, all you have to do is come back over here and delete this launch JSON, and then you could just make another one, same way we did the last one. But we'll come back over here and you can either hit F5 or you can pop over to the debug panel and just click play up here. So before we start debugging, I'm going to make sure I set a breakpoint. I'm going to hit F5, and now you can tell you're debugging because it has this little menu up top, which is like what you get in the sources panel in the Chrome DevTools. And if we come back to our site over here, this Chrome browser is linked specifically to VS Code right now. So if I close it, you'll see that the session ends over here. And if I hit F5 again, it'll open it back up. So the next thing I'll do just to prove that this is working is I'll add a breakpoint right there. And we'll come over and we'll trigger that breakpoint. Jump to the user page, and you can see right here, we're right there. And we can even, let's put a breakpoint right here and hit play. Our fake data call is resolved, and you could see filtered data equals an array, just like this. And you do get, in debug console, you do have this as well. So I could say filtered data. And this is kind of like what you get in the Chrome console. Also, your console out logs and things like that will show up in here. So now that we've seen that, I'm going to use the browser for all of this kind of stuff from here on out. This is impressive, but it's just impractical for me to be hitting breakpoints here and going back to the browser to look at other things. So like I said, I don't actually debug like this, but it is an option you have available to you. So I'm sure anyone that's ever written pretty much any JavaScript knows about the basic console log. I'm just going to go ahead and add a few to see when the data starts and stops loading. Clearly this error is on the user page and it's talking about updating state after the component has been unmounted. So I assume it's related to our data loading. So I'm going to come back over here, log in, go to the user page, and you can see here's our messages. And if I log out, you can see loading, then our error occurs here after it finishes loading. And so it gives you some idea that the problem is sitting in here somewhere. Now let me reiterate, this is not meant to be a good app. There's already a huge issue right here with the data being loaded even if there's no logged in user. But this is just a demonstration, so let's pretend this is not a dumpster fire and just continue on. So it's pretty clear that the state error is happening as part of the use effect reloading our data. So my next question is, why is this loading the data a second time? The use effect lists the filter as a dependency, so let's see what this filter data is when the page reloads. Maybe it's changing in some way? And with this, I'll show you something you may not have tried. Instead of just console logging out filter object, let's see it in a nice tidy table for comparing. Alright, so that looks pretty cool, but the table data looks wrong. Table display is not great for complex objects, but it's really nice for stuff like arrays or objects with basic properties. Anyways, let's look at a better way to visualize a complex object like this in a console. For that, we're going to use JSON stringify. You may have used JSON stringify, but something that's interesting about this are the optional parameters in there. The second parameter of stringify is a replacer function, which honestly I've never used, but the third one is either a number of spaces you want to add for indenting or some custom string to use for the indenting, which really cleans the output up a lot. So if I come back over here and do this again, now you can see our objects look really nice in the console. Alright, so while we're here, let's just pretend that our console log has maybe all kinds of stuff in here. So let's try another thing that's kind of interesting, and that's styling your console output. This probably seems kind of trivial, just coloring your console output, but sometimes when you're debugging a lot of stuff, like maybe you have all kinds of different metric systems on your site or something, having different colors in the console can really make your different logs stand apart from each other. Now let's pop that error again and see what the filter looks like on the second call. It's interesting, the filter on both calls actually looks the same. So it's probably not the filter dependency changes that are getting picked up and rerunning the use effect. So let's think, what else could be causing this to reload? Let's see if the component is getting remounted for some reason by adding console log messages on mount and unmount. Of course, these are functional components, so I'm going to use useEffect for that, which is really a close approximation to the mount and unmount lifecycle events from classically like class-based React components. But in this case, they're close enough. It's fine. Note the use of the empty dependency array on this useEffect. This makes the useEffect only happen on initial mount of the component. If I omitted the dependencies altogether, this would actually happen kind of on every render. And of course, if I actually included a dependency in this array, it would only trigger the useEffect when a dependency changed or was initially set. Also, in case you haven't seen this, the return function on useEffect fires kind of like a cleanup for whatever context the useEffect is in. That's a pretty crappy description of it, but in this case, it fires when the component unmounts. All right, so we could see a pretty clear picture of what's going on now. the component is unmounting and remounting when we log out, which then starts loading data again with a default filter. And when the data does come back, our code tries to update state, which then fires an error because obviously our component is gone by that point. So let's see if we can figure out why the component is rendering a second time, and for that we're going to use the React Profiler component. This is a cool little tool you can use for tracking component renders more closely. You might ask yourself, why not just drop a console log right in the component itself to see when it's rendered? Well, you might be surprised to see that it's not really going to be accurate. When using the Profiler component, you have to give it an ID and an onRender callback function. When this function gets called, it passes many parameters back to the function to give you a little more insight into the render taking place. When I use something like this, I don't usually use the parameters that often. You can also use many different Profiler components at the same time and even embed them inside each other. As you can see, when we update the filters on the user page, our original console log output is getting called twice as much as the actual component re-renders. That's a story for another day, but now we know we have a more accurate way to get insight into when the renders are happening. Now what I usually use the Profiler component for is dropping a programmatic breakpoint in a callback function so I can dig through the call stack and try to figure out what caused the re-render. This process can be pure pain as you'll have a lot of noise in your call stack, but sometimes it helps, so let's take a quick look at that. As you can see, this is our onRender function right here. We have our debugger. And right here is the whole call stack, which can be not much fun to weed through, but sometimes when you're all out of options, this is something that you can turn to. Usually the easiest thing to look to here is to scroll all the way down to the first event in the call stack and see if there's any information here that can help kind of shake loose what's going on. As an example, if I filter this data, when I click apply, you can see our render got caught here. And if I scroll all the way to the bottom of this call stack, inside of this dispatch event right here, we could see what called it was actually a mouse event, and it was a click, which makes sense because I clicked apply. So that is the original event that spawned this onRender ultimately. And another slightly more advanced version of this would be moving the callback so we can set a conditional breakpoint. This is a really cool way to say only break when very specific conditions have been met, which can be a useful way to trap certain scenarios and take a look around the call stack. Okay, so now you can see we're only going to trigger this breakpoint when the filter phrase is just one single D. So if I save that and pop back over to the browser, I'm going to go ahead and hit play. It's worth mentioning here that you can introduce instability with the Webpack hot module reloader by having breakpoints and reloading the page. So whenever possible, if you're paused, make sure you hit play and let the page reload itself automatically. If for some reason that's not going to work for you, you're most likely going to have to just copy the URL, open a new page, paste the URL, and start your debugging from there. Because just reloading the page while you're paused on a breakpoint will sometimes lock the whole page up. So anyways, let's go back in here. We'll do a filter, right? And then if I do another filter here, you can see the D triggers this. And so now I can take a look at the filters, and of course I can go back through the call stack and see why did this re-render happen, and of course it's a mouse click. While we're here, I'll show you a slightly different way to do this, which is going to seem kind of pointless in context here because I just showed you how to do it with code, but I'm just going to put a line inside this callback function. It does not matter what it is. It could have been temp equals 1. The point here is I just need a line inside this function to set a breakpoint from inside the browser. So if I go ahead and save that and click back over here, again, I'm going to hit play and not just reload it myself. We'll log in, we'll pop back over to the page. And so now, obviously, if I put a D in here, it's not going to stop. We have no breakpoints anymore. But you can see my code right here. I'm going to put a breakpoint in Chrome, but I'm going to right click and edit this breakpoint. And this is a different way to set a conditional breakpoint. And what's cool about this is that you can set conditional breakpoints in code that you can't actually alter. So if you can't add a debugger with an if statement around it, you can always do this. So I'll come in here, and of course we're not going to get autocomplete here, so it could be a little bit trickier, but I'm going to say filter.phrase equals D. And so the whole idea here is this breakpoint only gets hit if this evaluates to a truthy value. So I'll save that and we'll filter. Of course, I'll just type third and it doesn't hit, but if I put a D in here, there we go, it hit. And then surprisingly, you'll see the phrase is D. And as usual, we can look at the call stack. So this method of breaking the code and sifting through the call stack should never be your go-to debugging method. This is going to tend to be very slow and very tedious, and you may also find some false flags in here because a lot of times you're going to be just interpreting what you're looking at and maybe not getting things that are very obvious. But if all else fails, this is an option for you. So I would keep this in your back pocket. So just so I don't forget the whole point of actually adding these breakpoints, let's come back here, let's set that breakpoint. Look at our console logs here and see, okay, we hit once. I hit play, I'll log out, and we don't hit a second time. So we could see that it only actually attempted to render once, which is consistent with what we've already seen. So none of this breakpoint business really gave us any more obvious insight into why our component is remounting. Although now we could see that it's not rendering a second time, which is an interesting fact. Now let's roll out something else you should be familiar with if you use React on a regular basis. The React developer tools. This can be found in your browser's extension marketplace, so let's install that for Chrome now. Of course, I already have it installed, but this is where you would do it. So once you do have that installed, you should see them in your browser's dev tools. You may also have to close this tab and open a new one to see them show up in the dev tools. They don't usually just appear with a dev panel that's already open, I find. The first thing we should check out is the component display. As soon as I install this on a new browser, I always come in here under General, and I choose Highlight Updates when component renders. This is a handy way to keep an eye on how often things are updating. So we could see if I come over here and hit Login, you'll see the gray boxes that show up around everything. And these are just elements that are being updated in the DOM. But this is an easy way to see when you have components that are just constantly updating themselves. So before I show you any more about this, I should actually pull out the React profiler just so it's not pausing our code. Okay, so now if I log in and I go back to the user page, I could pop over to the components panel again, and then we could click the user page and we could see things like the state that's on the user page, any hooks we have set up. So this is already a pretty cool way to get some more insight into your components. And you can even do cool things like dump the state on the component we're looking at to the console, and then store parts of it as a global variable for comparing later. Another cool feature is clicking the component and jumping to its DOM element. So we can click this user page and click this little eye here and jump over to the elements panel. And now we're inside the user page. So this isn't always like the most useful part of the DOM that it sends you to, but if you're not familiar with a project and you're just trying to get your bearings on what is what between the elements and the actual React components, this is a cool way to work. And another example of something like that would be selecting something inside here. So I don't know, let's choose the header. And when we go back to the components, any element that you have selected from the Elements tab, this will try to forward you to the component that's from. In this case, it took us to the context provider for some reason, but if you've got a much more fleshed out componentized React app, this does usually work pretty well. If you really have no idea how things map between elements and components, this is a good way you can start to put a picture of that together. And finally, if you choose a component, you can also come over here and view the source for it. And this is yet another way to kind of get your bearings for how the components you're looking at map to the code that's in your source code. Since we're in the dev panel clicking around, let's look at a few other interesting ways that you can set some breakpoints to try to track down issues. Let's set a breakpoint for any time an element changes inside our app. And then we'll click a button to force something to change so we can see it. So you can see the code broke while trying to remove children from the DOM. And again, like our other breakpoints, we can just scroll down to the bottom of this call stack and take a look at what started this chain of events that makes it want to change the DOM. To remove that, you can come over here and just uncheck that, or you can come back to the sources panel and scroll all the way down here, and you'll see your DOM breakpoint there, which we can just remove. You can also break anytime an app tries to load data from maybe your backend or some other service by adding a new XHR fetch breakpoint. You can either add a blank one, which will break on any calls being made out to a server, or you can give it a URL and have it break anytime the URL has this phrase in it. While we're talking about debugging issues with calls to servers, here's another interesting little thing. I'm going to pull up Amazon real quick to demonstrate this because our site doesn't actually make calls back to any servers. If we come up here and we pop over to the network tab, just wait for this to load, clear all of this noise out. As I type into the search tray, you can see it making calls out for suggestions to show as you type. This could be your website requesting any kind of data from any other place, submitting a form, anything like that. So let's say maybe the problem here is we think the backend is returning bad data sometimes. We can click on one of these and see any of the form or query data going out, and we can see the data coming back. There's a lot of really useful information here for triaging problems. Stuff like headers, the timing graph, etc. But something I think that is probably less known is being able to copy these calls in all kinds of different formats. Then they can be pasted into the console or other places and replayed, which is really useful for pinging an endpoint over and over and seeing what you get back. They're available in all kinds of formats, so it's really cool. Anyways, we still aren't getting any closer to finding out what's causing our user page to remount, so let's give the profiler extension a try. Before we do though, let's go back into the settings and make sure we enable recording why each component updated. Sometimes this can give you useful information, so I always leave it enabled. So now that we have this panel open, I'm going to relog in, jump to the user page, I'm going to hit record in the profiler, log out, and then we're going to stop recording. Now we can see a graph of all the commits that happened during recording. The taller the commit in this graph, the longer it took to complete. This is really useful for looking for performance problems. If we step through all the commits, we'll see the first thing that happens is the user context wrapper updates. Then everything under it updates. If we look at the reason, it says it's the first time they're rendering, which is interesting. It implies to me that these things must have been removed and put back, including the user page. And on the next commit, we could see the router finally kicks in and bumps us to our home page finally. So right here we could see that after the user context changes, it looks like that's what's remounting the user page, and then immediately the router flips us to the home page. All right, now we're getting somewhere. So let's look at the user context and see what we have. As we can see, all signs point back to the update user function, so let's start there. What I'm going to show you here is another one of those processes that's really kind of a worst case scenario, but sometimes you just have to use brute force to search for answers. So let's just rip things out one at a time until our problem goes away and see if we can isolate exactly where the problem is. It's really important to pay attention if you're going to go this route though, because you could actually break things in a different way by removing stuff. So you need to know that enough of your code is still going to work to prove that the issue has went away or not, and you haven't just busted it completely. In this case, I'm going to start at the top, so let's get rid of the loading state update. And because I'm removing the first load state set, I'm going to get rid of the second one as well since they're related. Let's come back over to the page and see what happens. Log out. Interesting, so we can see the error actually went away without the load state sets. So what would the loader have to do with this? Let's come back over and see what it's actually doing. So as you can see, when the loading is true, we actually remove the children and only show the loading display. And because the context wrapper is actually wrapping most of the rest of our app, not rendering the children means we're literally removing the rest of the entire site until loading is complete. And now things are making more sense. Our user page is getting ripped out of the app while the user is logged out, then put back, and then immediately the router jumps to the home page, which explains why we were never getting a render after the remount, because the page is unmounted before the render even happened. But our useEffect call is still in progress while that's happening, so the data loads and our code tries to update state on a component that doesn't exist anymore. So if we go up and look at our update user function again, you'll see that we're bouncing to the home page after we set loading to false. And that's the problem. If we slide this up just one line, when we set loading to false, the router is already pointing at the home page, so our user page never gets remounted. Let's go ahead and give that a try. All right, so you should all be very proud. We've solved the Scooby-Doo mystery. Now let me show you just a few other useful apps for tracking down issues. These are all in line with kind of what we talked about earlier, making calls to a backend and triaging issues with data you might be getting back from them. So what I'm going to do here is I'm actually going to go over to Amazon again. I'm going to search for something. Let's see, I'll just clear that out. I'm going to search for something, and then I'm going to type a second letter. And we can see in here the suggestions that are made. I'm going to filter by XHR calls. We can see these suggestion calls here. And these are obviously the suggestions that come back in this little drop-down box over here. So I'm going to take the first suggestion call, copy the link address, and I'm going to open an app called Postman. Postman is a really cool app for forming different kinds of requests and customizing all the different parameters on them. And then we can look at the data that comes back. I could do a whole video on Postman by itself. Right now I'm just going to give you just the smallest taste of what it is. But this is one of those things that just learning a little bit will give you a lot of extra tools for debugging problems. So this is a really cheesy example, but I'm going to go ahead and paste the link URL that I pulled off of Amazon. I'm going to resend that GET request, and you'll see the suggestion data comes back over here. And I'm also going to come back over here and copy the next suggestion call. And I'm going to pop that into its own tab over in Postman. So now we have the results from each of these two calls. And of course, we could go through here. This is a little difficult because I've got everything zoomed in so far. But we could go through here and compare all the values going out to try to get some idea of like what is different between these two calls. There have been times in my life where I've had to triage, like all the code looked good in React, but maybe some of the parameters going out weren't what I expected them to be. And you might have to look at something like this to go, oh, okay, so this super obscure parameter down here is actually not what I would expect it to be. Another thing you might have to do sometimes is take these results and compare them to see, maybe you make the call once and it's fine, but the second time you make the call, the data that comes back breaks your page. So what we could do is we can copy the results from the first one and use an app called Beyond Compare. Now there's a lot of different apps that people like for comparing text. I'm not necessarily suggesting this one above anything else, but this is what I love and use. So I'll paste my results from the first call there, and I'll paste my results from the second call on this side. And unsurprisingly, this is just going to point out the differences between the two. And so this is an easy way to triage. Maybe I have the same call happening twice. I expect the same data twice, but the second time it's hitting a different server on a load balancer and it's returning something encoded wrong or something weird like that. This would make those changes very obvious. One last app I'll point out here, and I'm really not going to get into this too much, is something called Fiddler. It's kind of like the network panel in the developer tools. And it's kind of like Postman, and it does a lot of other stuff. You can proxy from mobile devices through here. It's really, really useful and it's really powerful. So again, this is another one of those apps where you could do an entire video on it by itself, but it's worth knowing that it exists and just having some idea of some of the things you can do with it, because it will get you out of tight spots, especially if you have to triage really weird stuff like header problems or CORS issues, things like that. And if you're comfortable with Fiddler, you really don't need Postman anymore. Fiddler will do everything Postman will do, with the exception of maybe some of the tests and things like that you can do with Postman. So yeah, I think that covers pretty much everything. If you feel like I've forgotten anything, I'd love to hear about it in the comments. Or if you think I got anything wrong, I'd love to hear about it. Hopefully this video is useful for anyone that's sat through this much of it, and I appreciate you checking it out. Hopefully I'll see you again on another video.